examples for section 1.3 algebraic expressions. So the first example is just adding polynomials. So again, this is just combining like terms. So what I'm going to go through and do is find all of the different pieces that have the same exponents from each polynomial. And then once I've found those, then I'm just going to combine like terms. Now remember, when you combine like terms, you're only adding the coefficients, and the actual exponent is going to stay the same. So this will become 5x to the third minus 3x squared. There's no other x term, so that minus 5x just stays that way, and then plus 10. So there's our final answer for that one. Next, when we subtract polynomials, basically we're going to distribute that negative to everyone. So what I end up doing a lot of times is just rewriting the problem. And really I don't need those parentheses when I'm combining like terms, but I'm going to rewrite the problem and go through and change each sign from the second set of parentheses. So this was a plus 4x to the third. Now it becomes, now it becomes a minus 4x to the third. This was a minus 5x squared. Now it becomes a plus 5x squared. This was plus 3. Now it's minus 3. Now I'm going to go through and combine my like terms. So I have an x to the third and a negative 4x to the third. That becomes negative 3x to the third. I'm going to put little check marks down below to remind myself that I've already taken care of them. Then this becomes a 7x squared. Again, minus 5x, that's the only x piece, and then plus 4. So there's our answer for that one. When we multiply polynomials, there's a couple different ways to do this. First, we can talk about FOIL. Okay, FOIL just stands for first, outside, inside, last. So first means we're going to multiply the 4x times the 3x, 12x squared. Outside means the things far away from each other. That's minus 8x. Inside means the things closest to each other. And then last, those are the last pieces of each binomial. Now I do need to combine the like terms. And there's the answer for that one. Now, when we go and multiply trinomials, or basically anything that's not a binomial times a binomial, basically what we have to do is just distribute a bunch of times. So I'm first going to multiply x squared times everything. And we have to be really careful to use our exponent rules correctly on this one. Okay, now I'm going to go through and multiply 5x times everything over here. And finally, we're going to multiply negative 4 times everything. Now, unfortunately, there's not a great way to check your answers and check your work on this one. So you really just have to be careful and honestly kind of hope that you do everything correct, or else it's just kind of a tough, there's unfortunately no way to easily check. So there's my x to the fifths. There's my only x to the fourth. X to the thirds. I've got the 3 and the negative 8. So that's minus 5x to the third. So I've taken care of those. My x squareds, that's going to be plus 14x squared. My x's, negative 17x, and then the constant is just plus 4. So there's the answer to that one. All right, next, when we divide, we talked about basically just making fractions. So we're going to take everything from the numerator and put it over the denominator, and then we'll reduce. So because there's 3 pieces in the numerator, that means I'm going to have 3 individual little fractions. Once we get here, we just go through and use our quotient rule and just reduce fractions in general. So this one becomes 3xy squared. This becomes 2x squared y. And then this one becomes minus 5. We have to be really careful down here. If you had any addition going on down here, you actually could not do this unless we're able to factor some things out. So just be really careful. When we divide, we're only going to divide by a monomial for the time being. All right, now example 5, we're going to start using some special products. So as you're looking at your notes, there's a couple different formulas that will hopefully help us go through things a little bit quicker. So this one, when I look at it, I notice that it's the same math stuff in both sets of parentheses. One's a positive, or one's a plus, and one's a minus. So that's going to be the first formula that I see on my chart, which just tells me to take x squared minus y squared. So this chunk is the x, and then this chunk is the y if we're sort of using our formula. So I'm going to actually kind of rewrite stuff. Rather than foiling, I'm just going to kind of use my shortcuts here. So I need to find x squared, which we know is 4r to the 4th. I need to find this part squared, which is just s. And then based on those two little building blocks, I know that's our answer right there, 4r to the 4th minus s. Next, special product. This one actually uses the second one in the chart. That is x plus y squared is x squared plus 2xy plus y squared. So again, I'm going to sort of do the same thing. This is my x part. This is my y part. So the square root of c squared, that's just going to give me c. 2 times x times y. Right. This ends up being kind of a gross fraction, but if we just multiply everything across the numerator, we get 2 times the square root of c times the square root of c on the bottom, which actually, now that we see that, the square root of c's cancel out, and we get 2. So that one actually looks a whole lot better than what we thought it might have been. And then to find our y squared part, we're just going to square that other chunk, and we have 1 on the top, and then on the bottom the square root of c squared just gives us c. So then we can combine those three little pieces. So we'll have c plus 2 plus 1 over c. That's our final answer. If you guys want to sort of prove to yourself why these properties are so helpful, if you try to FOIL this out, you should get the same answer, but I will tell you that the work will probably be a little bit more difficult. All right, next, special products. This is the last one on the chart. So then the sort of shortcut looks like this. And again, this is my x piece, this is my y piece. So the first thing we're going to take is 2a to the 3rd. That's that piece right there. Then we're going to go minus 3 times 2a squared times 5b. We don't need to worry about the signs because all these little shortcuts, those already took care of the signs for us. We're just able to really focus on the actual coefficients and variables. Then we're going to go plus 3, and then we just get 1x, but then we get the y squared part, and then minus the 5b to the 3rd. Okay, now we're able to simplify that. 2a to the 3rd is pretty straightforward. It's just 8a to the 3rd. Over here, we've got coefficients. Now you have to be careful because your coefficient here is actually squared. So this is really 3 times 2 times 2 times 5. That gives us negative 60a squared b. Again, be careful here. This is 3 times 2 times 5 times 5. So that's going to give us 150ab squared. And then at the very end, remember we've got 5 to the 3rd, which is 125b to the 3rd. Okay. And that's your final answer for that one. Next, we're going to go through and just factor a ton of different ways. So this first one, a to the third plus b, 64b to the third. Usually I just go in order. So we start, I don't see a GCF. These are not perfect squares, but they are perfect cubes. So this is a to the third, and then this one actually is 4b to the third. Okay, so those are sort of my building blocks, and then I just have to put it into our formula. And this is our SOAP formula. So remember, the first part of the parentheses is just the building blocks. The second part of the parentheses, I'm going to square the first part, and then I'm actually going to skip the sign for just a minute. In the middle, I just multiply them, so that's 4ab, and then at the end, I take that 4b part and I square the whole thing. That's going to give me 16b squared. Now I'm going to SOAP this. So same sign as the original problem, opposite sign, and then always positive, and that one is now factored. Next, I immediately see that there are 4 terms. So when there's 4 terms, almost all the time we're going to factor by grouping. And then usually we're going to split it this way, the first and second together, the third and fourth together. So if I look at the first and second, I see I can take a 2 out. I cannot take an A out, but I can take a C. And then I'm left with 2A plus B. Okay, over here, usually when they're both negative, you're going to end up taking out a negative as part of the GCF. I can't take out a coefficient, I can't take out an A, but I can take out a D, which then leaves me with 2A plus B. All right, this tells us that we've grouped it correctly and factored it correctly because the leftovers right there, those are the same. So I'm just going to go ahead and take that and write it. That's half of my answer. And then the GCFs that we took out, those form to be the other factor. And now that problem is factored. Next example, I'm just going to guess and check. Now unfortunately in this one, A does not equal 1. So I just have to come up with some factors for 6. So I know 1 times 6 works, I know 2 times 3 works. Over here I know that this is going to be 1 times 3, but because of this negative, that means that one of them has to be negative. So it could be negative 1 times 3, or negative 3 times 1, or something like that. So I'm just going to guess and check. I'll start with the 1 and the 6. So 1x, 6x, and then I'll put negative 3 and plus 1. Okay. Now I know that the F and the L work on FOIL. I just need to check the O and the I. So the O would be 1x times 1, which is x. The I would be negative 3 times 6, which is negative 18x. I'm looking for negative 7, and that does not work. Okay, so I know that's wrong. Another couple little tricks here. If I just switch those, x minus 1 or 6x plus 3, something like that, if you'll notice, this would have a GCF in that factor. But if you go back up here, there's no GCF. So because there's no GCF in the original problem, I know that I'm never going to be able to factor out a GCF from one of my factors. So my guess is that 1 and 6 is not going to work. I'm going to try 2 and 3. So 2x times 3x, we'll go with minus 1, and actually no. Again, if we put plus 3 there, we know that's not going to work because there would be a GCF. So I'm going to put minus 3 there, plus 1. If I check my O and my I get 2x and minus 9x. That is negative 7x, which means that is the correct way to factor. So obviously this is just totally guessing and checking. I happened to screw it up twice, but some of you might have guessed right here to the final answer the first time through. All right, next one, 4 terms. So I'm going to factor by grouping. Let's see, my GCF here, I can take out an x squared, which leaves me with 3x plus 2. I can take out, again, because they're both negatives, I'm going to take out a negative 4, and that leaves me with 3x plus 2. That's awesome. Okay, now I know 3x plus 2, and then my other factor is x squared minus 4. Now, one thing that we've not had to do yet, but in this problem you do, right here, this is a difference of squares. Right? So when you're factoring, you have to completely factor. Sometimes you'll have to factor once, sometimes you'll have to factor more than once within a given problem. So this is a difference of squares. That means the relationship is not going well. We need to break them up. When we break them up, we remember the good times and the bad times. Next one, looking through this problem, I see a GCF from the constants. So I'm going to take out a 3 from everything. So this at least makes my numbers a little bit smaller. Not great, but a little bit smaller. And now I'm just going to guess and check. Again, I see 1 times 4, 2 times 2. I also see 1 times 9 or 3 times 3. I will tell you a lot of times it ends up being the factors that are closer to each other. So I'm going to try 2x. And then because you see this y here, that means we're going to get the 3y. Now this sign, this tells me that both of them have to be the same sign. And then this tells me both of them have to be negative. So I'm going to put them right there. I know that f and the L works. I'm going to check my O and I, and this is going to be negative 6xy and then negative 6xy, which is negative 12xy. Now be careful, because if you look back at the original problem, that's not right. But remember, we factored out GCF. So there is your correct answer. Next one, there's 2 terms. That tells us that we've kind of got a limited number of choices. And then looking at these numbers, I see that they are both perfect squares. So we take the square root of both of them, 5r 7s, 5r 7s, and we remember the good times and the bad times. There's nothing else to do on that problem, so that one is done pretty quick and pretty easy. Next one, nothing in the coefficients, but I do see everyone has an x and everyone has a y. So I'm going to take out as many as I can. I can take out an x squared, and I can take out a y. That's all I can take out from everyone. And then we're left with 4x squared minus 11xy plus 6y squared. Now, I bet that the trinomial there in the middle is going to factor again. Again, let's see, 4 could be 1 times 4, or 2 times 2. 6 could be 1 times 6, 2 times 3. And I'm going to try 4x, and then 3y, and 2y. Now, checking out our signs, we know they have the same sign. We know they're both negative. Check your O and your I. This is going to be negative 8xy. This is going to be negative 3xy. And that gives us negative 11, which is correct. Last couple examples. This one is a difference of cubes problem. So if we take the cube root of each, we see that this is going to be 2c squared. And then when we take the cube root of this one, we see that this is 3d to the third. Then we're going to use our SOAP property. So the first factor is 2c squared, same sign, so minus 3d to the third. Next factor, remember we need to take the first chunk and square it. So 2c squared squared gives us 4c to the fourth. Opposite sign, so that's going to be a plus. Then we just multiply those two things together, so 6c squared d to the third. Last sign, always positive. So I'm going to take my 3d to the third and square that whole thing and get 9d to the sixth. Last problem is a difference of squares problem. If we take the square root of both of these, we'll see this is 9x squared. This is 4y squared. So we're going to split them up to be the good times and the bad times. Now we need to check because this one can actually be factored further. Now the first factor, leave it alone because that relationship is happy. Don't be a home wrecker. Don't break them up because their sign is positive. However, this second piece, this is 3x, this is 2y, those do need to be broken up. So good times and bad times. So those are all of our examples for 1.3 algebraic expressions.